Hello students, good evening all of you. In this class, let us discuss some more questions from general organic chemistry. Okay, so it is also based on the resonance. So generally for molecules or ions, different type of resonant structures are possible, and we can give the order of stability for those resonating structures. Okay, so here in this case, this amine compound. Okay, so this one here given four structures. Among the four structures, which is the more stable and which is the least stable resonant structure. Okay, just we should here we have to write the stability order of the all possible resonating structures. Okay, so generally you know that a resonant structure with more number of covalent bonds is more stable. Okay, a resonant structure with more number of covalent bonds more stable. That means here the resonant structure without charge separation, without charges, is more stable. Okay, that means a resonant structure with more number of covalent bonds is more stable. It means a neutral resonant structure is more stable than the charged resonant structure. And secondly, a resonant structure must have the octet configuration on all atoms. Okay, all atoms must have the octet configuration. Okay, so then it is also stable one. And next, negative charge on the more electronegative atom and positive charge on the less electronegative atom is more stable. Okay, a resonant structure with negative charge on the more electronegative atom, positive charge on the less electronegative atom is more stable. Okay, so here in this case, see this one. And one more point here, if similar charges or opposite charges are present on the adjacent atoms, those are the least stable resonant structures. Okay, for suppose here in this case, similar charges are opposite charges. Here opposite charges are present on the adjacent atoms. These two are the least stable resonant structures. Okay, now here which is the more stable resonant structure? As per the rule 1, here this compound has a more number of covalent bonds. It means it is a neutral one. So here the A is more stable. Okay, the resonant structure A is more stable one. And here second one. Here in this case, here there is a octet configuration. Here around the nitrogen, okay, around the nitrogen 4 bonds are there. There is a octet configuration. Here in this case also, 2 CH bonds, 2 CH bonds, here CC bond, and here 2 electrons, so here 8 electrons totally. That means here every atom has a octet configuration. Okay, but it is charged one, it is a neutral one, so neutral one is more stable, it is a charged one, a secondly stable. Here in this case there is octet configuration, here there is an octet configuration. But here in this case, CH plus, this is not an octet configuration. Here only 6 electrons. This is the positively charged carbon, no electrons. Okay, just here 3 bond pairs, that means 6 electrons. So here no octet configuration. Here similarly no octet configuration around this carbon. So these two are least stable. First two are more stable. So A greater than B. Okay, because B is the charged one. That is less stable than the neutral one. Now here next, between these two, which is the more stable? Here actually this compound CH double bond CH, this one is the NH2. Okay, here NH2 is the donating group. This NH2 is the donating group. By donating lone pair of electrons, this pi electrons transfer to this carbon, and then this pi electrons transfer to this carbon. Okay, it means here by transfer of these pi electrons, it carries a positive charge. Here it carries a negative charge. Here it carries again positive charge. It carries again negative charge. Okay, so it is based on the flow of electrons, because it is NH2 is a strong, there is a plus M group, electron donating group. So flow of electrons towards this side. So here this carbon must have the positive charge. Okay, raising of the positive charge is supported by the NH2. Here raising of the NH2 is not supported by the NH2. And additionally here electron density, here electrons repel each other. So this is somewhat acceptable structure, because this polarization is based on the NH2, based on the nature of the group. Okay, so this is somewhat acceptable structure. So here C and then D. Here D is the least stable structure. Okay, D is the least stable, because here this polar form is opposite to the nature of the NH2. For suppose if that is withdrawing group CH bond CH bond CH C double bond O H, if it is a withdrawing group, here flow of electrons different. Here that is withdrawing group minus some group. Here pi electrons transfer to this one. So carries a negative. This carries a positive. Pi electrons transfer to this one carries a negative. Here carries a positive. It is a polar form. In this case here, the negative charge on this carbon is acceptable. Here the positive charge on this carbon is acceptable. Okay. So here in this case, based on the nature of the group, we should say the here either positive charge on the carbon or negative charge on the carbon. Okay. So here this polar form must be written on the basis of the nature of the groups. So it is a donating group. So here this is the acceptable structure. Here C double bond OH or NO2 group, those are the withdrawing groups. Here negative charge on this carbon is acceptable or negative charge on this carbon is acceptable. Okay, that's it. So the least stable resonating structure. That is, this is the previous type of question actually. Okay, which of the following is the least stable structure? Here NH2 or we can write the OCS3. In this case also OCS3 donating. So here in this case, this carbon can have the positive charge and this negative. Here positive, here negative. If it is also NO2, NO2 is also withdrawing group. Okay, so based on the nature of the withdrawing group, yeah, this carbon must carry the negative charge because flow of electrons towards that electron withdrawing group. Okay, carrying of the negative charge on this carbon is feasible. Here, the carrying of the positive charge on this carbon is feasible. That means acceptable. Okay, it is the least stable resonance structure. That's it. Okay, so next one more question. The stability order of these resonance structures. Okay, actually this molecule is known as a ketene. Okay, this molecule is known as ketene. So what is the stability order? Okay, as per the rules, the neutral one is more stable. Okay, this one has a more number of covalent bonds. So A is more stable. Okay, next here, remaining three resonance structures are the charged one. So they are less stable than the neutral one. Okay. So here in this case, this one is the least stable. Okay, this may be least stable or it may be least stable. Because around this carbon only how many bonds? 3 bonds. That means here 6 electrons. Around this carbons again 6 electrons. Okay, no octet configuration. Now here this negatively charged carbon has 8 electrons. Okay, here 3 bonds and negative charge is nothing but 2 electrons. So there is octet configuration on this carbon. And here 3 bonds and here 2 electrons. There are 8 electrons. So the 2 atoms have the octet configuration. So D more stable. So generally we can think this one. Here more electronegative atom oxygen carries a positive charge. Okay, but it is a more stable. Here less electronegative carbon atom carries a negative charge, but it is a more stable because first we have to give the priority for the octet configuration. First neutral one and then you have to give the stability order based on the octet configuration. Every atom must have the octet configuration. That is the more stable resonance structure irrespective of the charges. Okay, so here O plus CH2 minus. This is the more stable resonance structure because all atoms have the octet configuration. Okay, irrespective of the charges. Now coming to this one, here 6 electrons, here 6 electrons. Here this oxygen has a 8 electrons and this negatively charged carbon also has 8 electrons. That means here one atom has no octet configuration, but here between these two now deciding the stability the based on the charges. Here carbon carries a positive charge, here carbon carries a positive charge. But here the less electronegative atom carbon carries a negative charge. Here the more electronegative atom oxygen carries a negative charge. Okay. So here negative charge on the more electronegative atom is stable. Here negative charge on the less electronegative atom carbon is less stable. So C more stable and B is a least stable one. Okay. First neutral molecule is more stable and next every atom must have the octet configuration and next okay, if all atoms have the octet configuration then based on the charges. Okay, first you have to give the priority for the neutral molecule, next for the octet configuration and next charges. Okay, so here these two ions, these two resonance structures have no charges, but here there is a C plus, here C plus, here CH2 minus, here O minus, here O minus stable when compared to CH2 minus. Okay, because more electronegative atom hold the electron density very tightly. Okay, so that is the stability order of these resonating structures. Okay. Okay, so next one more important point in mesomeric effect, that is it is a numerical type question. How many of the following can acting as both plus M and minus M groups when attached to the benzene ring? Okay, so here in this case, so plus M group, a group to be acting as a plus M group that must have non-bonding electrons. Okay, like this one acting as a plus M group. Okay, so group must have the non-bonding electrons that is acting as a plus M group. Next, to be acting as a minus M group, that must have the multiple bonds. Okay, that must have the multiple bonds. Here is N double bond O. Here there is a pi-pi conjugation. Through the pi-pi conjugation, that group withdraw electrons from the benzene ring. Okay, so or suppose C double bond O H aldehyde group. This one also has a multiple bond acting as a minus M group, electron withdrawing group. Okay, it is a plus M group, electron donating group. So here in this case, the group must have the non-bonding electrons or multiple bonds. Okay, that is. So here acting as a plus M as well as minus M. So here in this case, this one has a lone pair of electrons acting as a only plus M group. This one also has a lone pair of electrons acting as a only plus M group. Okay, lone pair of electrons are transferred to the benzene type. Now here in this case, multiple bonds, this one acting as a minus M group. When this group is attached to the benzene, a pi bond here, pi bond, here acting as a minus M group. Okay. So the point is, the interesting point is C double bond O oxygen. Here, when this oxygen in the same group, this oxygen attached to the benzene acting as a plus M. Now here, if the benzene is attached to this carbon acting as a minus M group, okay, based on the bonding we can say. Here, this benzene has a plus M effect of this lone pair, this benzene has a minus M effect of this C double bond. Okay, but here in this case, there is a CHC group is given here. Benzene is attached to the C double bond O, so that acting as a minus M group only. Okay, that's it. Here in this case again plus M group, that is the electron donor. Here in this case here, coming to this one, so very interesting this one, NO group. Okay, so here in this case, this one here NO when attached to the benzene can be acting as plus M group because non-bonding electrons are there acting as a plus M group. Okay, now next pi bond here, pi bond, this one N double bond O. Okay, here there are the multiple bonds, so also acting as a minus M. This is the minus M group, here plus M. That means here the same group can be acting as a both plus M as well as minus M. Okay, because attached atom has a non-bonding electrons and multiple bonds. And next here coming to this one. Here also same, when attached to benzene, this one acting as plus M as well as minus M. So lone pair of electrons are there, so plus M. Okay, lone pair of electrons are there that can acting as a plus M group. Okay, now here multiple bonds are there, so here plus M as well as minus M. This one plus M as well as minus M. Okay, now here Cn. When Cn is attached to the benzene, okay, here only minus M effect because here carbon has no non-bonding electrons, only minus M. Next here chlorine, coming to this chlorine. So chlorine is a different case. Here bond, here chlorine. So because of the non-bonding electrons acting as a plus M group, because of the non-bonding electrons acting as a plus M group. And this one also acting as minus M group also. Okay, minus M group also. Why? Because this chlorine has a vacant d orbitals. This chlorine has a vacant d orbitals. So because of this chlorine vacant d orbitals, here pi electrons can be delocalized into the vacant d orbitals. Okay, these pi electrons can be delocalized into the vacant d orbitals. So that's why it is acting as a minus m group also. Okay, plus m as well as minus m. Okay, very very important point. Now here in this case, this one has no multiple bonds. So yes, methyl here plus. No multiple bonds and no lone pair of electrons on the sulfur actually. Okay, of course here in this case there is a one lone pair here, two non-bonding electrons, but here cannot acting as a donor. Okay, because already that has a positive charge, and now here this one acting as only withdrawing group. Okay, that can acting as only withdrawing group because of the sulfur has a vacant d orbital. So this one acting as a minus m group. Okay, acting as a minus m group, but cannot acting as a plus m group. That cannot acting as a plus m group, even though that has a one lone pair. But here in this case, okay, here in this case, already sulfur has a positive charge, so that cannot acting as a plus sum group, acting as a cannot acting as a donating group. So only that accept the pi electrons into the vacant d orbital of the that sulfur. So only minus m group. Okay, of course as well as minus a group also. Next here coming to this one. Here no non-bonding electrons, so only multiple bonds are there. So acting as a only minus m group. But here in this case there is a non-bonding electrons, multiple bonds acting as a both plus m as well as a minus m. Okay. And next here coming to this one. Here non-bonding electrons are there, so acting as a plus m, and multiple bonds are there acting as a minus m group. That means here just here like this one. NH. Here this is a NH in the place of oxygen, NH. So acting as a plus sum as well as minus sum. Now that's it. Okay. So here the groups which are acting as a plus sum minus sum are only here 1, 2, 3 and here 4. Okay. Here among the given groups here 4 groups are acting as a both plus sum as well as a minus sum. Okay. The main key point is sulfur also acting as a yes, the chlorine also acting as a plus sum as well as a minus sum. Plus sum by donating lone pair of electrons, minus sum by attracting electrons into the vacant d orbital. Okay, in this case lone pair and multiple bond, lone pair multiple bond, here lone pair multiple bond both. Okay, here only multiple bonds are there, so minus m. Here only lone pairs are there, so plus m. That's it. And next here one more important point, this positively charged group cannot be acting as a plus m group because already that is electron deficient, so no more can acting as a donating group. So that's why the only withdrawing group, that is the minus m group, because sulfur has a vacant d orbitals. And next one more interesting point, as like halogens here, SH group also acting as a both plus m and minus m. SH group also acting as a plus m as well as a minus m because of the vacant d orbitals in sulfur acting as a plus m as well as a minus m. Okay, but in this case already positive charge is there, so cannot acting as a donor but accepting the electrons into the vacant d orbital, so that's why minus m. Here in this case plus m as well as a minus m. Okay, that is a very important point. Now here another point, the benzene when attached to NH2, that means your plus m group, here phenyl accept the electron, that means here acting as a minus m group. When benzene attached to the NO2, not only NO2, whatever the electron withdrawing group, here the benzene donates the electrons to the NO2, so that means it is acting as a plus m. So phenyl group also acting as a plus m as well as a minus m. Okay, phenyl also acting as a plus m or minus m, based on the nature of the bonding group. Okay, so NH2 donating, this one accept the electron, so minus m. NO2 withdraw electrons from the benzene, so it loses electrons, so it is a plus m group. Here phenyl group acting as a plus m, here phenyl group acting as a minus m. Okay, so that's it. Thank you for watching.